So welcome to developers meeting on Sunday, the 15th of January, 23. Yeah, we were just talking about MKV files and that I rehearsed Mike, Yannick, David, and who else? Sorry, Lionel received the disk with the MKV files, but these MKV files are corrupt in header. Because they're made from an old software. Anyhow, David made a tool, it's on GitHub, and it corrects the header. It creates new videos with corrected header. So we call U4 just to run David's script and to update your MKV files, please. Yeah, sorry for this, but it will certainly help in your codes to give correct FPS and timestamps, I assume. All right. Before we go into details, and what I want you is, let's say, a kind of an update of your last weeks over the Christmas weeks, for example, when you had some time to do stuff, just to give us an update on where you are at the moment. But before we go into this, I just want to tell you that as you know, we have a donation that is, let's say, bound to a wish of the donator to use it to set up stations. But because we are not there yet to have a final system, we said we will invest the donation into hardware that is used for development. And so we made the decision to buy some cameras and optics and Pis and 2 NUC boards and also 4 enclosures and give them to some developers, especially those who are involved in the development of the alpha version. And I had contact with many of you and we're talking about this, and we came to a final list for now. And yeah, I just want to run it through this list so that you're aware of that you get some hardware within, let's say, 1 week up to 4 weeks. So there's different hardware coming your way, but with different timings in between. It's not one package, it comes probably in 4 packages. And one thing is the organization purchases this hardware, and we will run a list of you who are granted this hardware for keeping it in custody for Sky360, meaning that these products will still be in possession of Sky360 and hand it over to you for development reasons or testing reasons, and to keep them in custody until you decide by yourself to, let's say, go apart with Sky360. Then we would ask you to return the hardware. So I'll just run you through quickly who receives what. I am on list first. Oh, that's funny. I get a Pi5. That's it. Oliver gets a Pi5. Christian receives a NUC. Will come tomorrow. And also a Pi5. Bojan will receive a camera and an optic and a Pi5. But Bojan, some of this can still come to the prior address. I know that you're not here online right now, but if you see this video, please be informed that some of this is coming to the old address.
I think Bojan is stuck at internals and wondering why nobody is there. I'm going to tell him right now that he...
Okay.
Yeah.
Okay. So next is Brad. Brad will receive a Pi5. Jump. Tommy Goodson will receive a Pi5. Joe in Australia, nothing for you because we focus for developers who are on the alpha version and for developing and testing. So I have to skip all developers who are not directly involved into this. So this was a decision we did because even this donation is limited, and so we had to use the money most efficiently on our needs, on our most needed ends. Ido will receive a NUC, yeah, only. Mike will receive a camera, a optic, and a Pi. The same is for Yannick. Yannick, you will also receive a camera, an optic, and a Pi. Mike will also receive.
Thanks.
Mike will also receive. No, don't say any thanks. It's no gift to you. It's just
Okay,
working
I
hardware.
understand.
Okay, you just have to
Yeah.
agree or not agree.
All right.
Okay,
I
it's
agree.
no gift from our side. Okay. Michael, I have to add. Hey, by the way, Michael's here. Hi, Mike.
Mellow greetings.
Hi, Mike. Did you just hear what I said? I
just got a.
Michael, sorry, Michael. I was talking to Mike G. When I'm referring to you, I always say Michael, the full name. Okay, that makes a difference for me at least. Okay. Hey, Mike, did you just get what I said before about development hardware?
Yeah.
Yeah. Okay.
Thank
So you will receive an enclosure, the camera, the optic, and a Pi5, right?
Okay. Thank you.
No, don't say thanks, please. Again, this is not from Skype 60. It's provided to
understand.
you
I
for
understand.
work purposes only, work and testing, developing and testing purposes.
I understand.
So you can
So
only,
thank you anyway.
Mike, you only can say you agree, you accept it, or you don't.
Okay.
Okay. So Yannick, we had already. Next is Fabio. Fabio will receive the camera and the optic. You will not get the Pi because you already have a Pi5, right? Got it? Right.
Yeah.
Lionel is not here today, but Lionel, if you see this, you will receive an enclosure because you said you can put it on your roof. You will also receive the camera, the optic, and the Pi5. Rebecca will receive the camera and the optic and the Pi5, but not the enclosure because she will not be able to set it up at the moment. Michael, Sandler, all right? Michael, you will receive the enclosure. Sorry, sorry, Michael, but I can't get out of this image of my head. You will receive an enclosure, the camera and the optic, and the Pi5.
Fantastic.
And the last one is David. David, you will receive an enclosure, a camera, an optic, and a Pi5.
Right. Thanks.
All right.
No worries. I agree.
Perfect. Okay, just remind you guys, it's only in your custody, so it belongs to Skype 60, and whenever you leave, just please send it back so that other developers can use it. That's the way we want to use further donations as well. So whenever hardware is needed, we try to find a budget for it, so to provide this. I mean, we're not talking about USB sticks or, a USB cable. Always talking about things that at least cost more than $100, something like this, or are hard to procure. All right. Any questions to this? Okay. No questions?
Yes, please. I've one. What happens if it breaks in our custody?
It's broken. That's a test equipment that's broken. That's it.
Okay.
No refunds involved. Absolutely not. No, you do not have to refund it. You also can say, if you want to leave us, I break it, and then I leave you, kind of. But hey, it's a fair play here. We just want to use this hardware for you to be able to develop on this, because we cannot ask developers to spend their time and brain, and also to invest the money in the hardware. At the end, it will be becoming costly for developers, and we do not want to see this, because your donation is not money. Your donation is your brain and your thoughts and your knowledge and what have you. Okay. So that's why we differentiate. Maybe there's a developer who's also a donator, can happen, but more or less two groups. All right. So if there's no further question on this, I mean, the order is just placed. The Pi orders is not placed yet. The Pis will be ordered in the next couple of days, because I still have to decide on the supplier. The Pis will certainly take 3 weeks until arrival. Okay. The cameras and the optics will be quicker, and the NUC, Ido, your NUC will certainly take another week.
That's fine. Thank you.
Yeah, and Christian got the same NUC. I just bought 2 of them. And the idea is when you compile something, that Christian can also recompile it, so that we have always 4 eyes on one thing.
Yeah, we are, at the moment, we do things in parallel like that, so it makes sense that we fly in parallel on the NUC too.
Exactly. That's the idea. So, why not start with some updates from your side? Why not start with, I heard that you just posted it, Ido. I start with you. You posted that NIX OS now got the pull request for the finally accepted libUSB changes and FX load changes. Is this true, or can you put it in your words?
Yeah, so a small correction. So it's actually merged from staging to master, and it's waiting now to be pushed to the unstable branch. And once it's in unstable, it's going to be on the unstable version, and then when it moves to the stable, it will be on the stable version.
Okay, it means that from that on, it's you can pull it from NIX OS. Everyone can pull it from NIX OS.
Yeah, it's on the way to make it happen. Yeah.
Okay, so we'll take a couple of more days, right?
I hope. Yeah.
Yeah, let's cross fingers.
Yeah.
But is this a kind of a blocker for you right now?
No, I actually do other stuff. So I tested the camera this week. I was able to get up to about 13, 14 frames per second before the Indy driver collapses and dies. Still trying to figure out what's the proper configuration for it. Yeah, but I don't know if it's the camera driver that it's unstable, if it's Indy that it's unstable. I'm trying to figure that one out.
Did you cross-check with Christian? Christian, what's your experience here? You're using the same hardware, both of you, right?
Yeah.
Okay.
I'm not sure what the question is about at the moment.
No, there's no question. I just need to find the right Indy configuration.
Okay. That
to
one.
Get to the max frame per second.
I was still at the point where NIX OS is providing the package and has to migrate it to the unstable branch. We are going to synchronize the efforts on how to set up Indy and how to use it with existing camera control software. For me, on my Pi4, all the cameras I have, not only the QHY camera, are working fine. I could set up the Mikey optic and the other optics, and I'm reviewing the adapter for the Mikey to the QHY camera at the moment, because I think we have to alter it a little bit, but that's, I think, only on my side, because my Mikey Optic has some small arrangement in the ring. And I think the actual adapter version needs a widening in the screws holes. But when I fix that, we will have, I think, version 2.1 or so. But this is already in the print, and yeah, if I have got finished about that, Ido and me will talk. We'll have a live video conference and set up the system for him in parallel with mine, so that we can verify that the setup process, has the right steps.
It's the same.
Yeah.
So
Alright.
I did some more digging on supporting NIX OS with Orange Pi5. The kernel is not available yet, and that's like the main issue. So there are some people that are poking and trying to figure it out based on a previous board they have, but they didn't release the kernel yet for the Pi5.
But for Pi4, it's working.
I don't know. I don't have a Pi4. Again,
okay.
Orange Pi5. Sorry. Okay.
So I think I can help out with that. I have two Pi4s at the moment, so I just need the image to
Well,
test it.
You mean the Orange Pi4 you have?
No, I've got normal Raspberry Pi 4s.
Yeah. So Raspberry Pi 4 right now it's on hold until they are merging it to master, and then I can continue with the support of the IndieFull to compile it on ARM. Okay.
Yeah.
I already have the code, so that's not an issue.
So we can do a pre-compilation for the image ourselves.
For what?
For the image of the for the Pi 4.
For Pi 4, we already have a base image. Okay, that has a Sky 360 user. It's working. I actually did a few more stuff on it. I will release them this week. But
let's test it tomorrow.
Okay. Yeah. But what I did, not to be blocked, is I released a Docker image that will actually patch the host machine with the UDEV rules and FX load, with the QHY SDK that we need, and that's working fine. Okay. But again, the driver, at least the new one, I think I'm using like 199. I don't know the one before that. It seems unstable. I can say like if I boot and I'm starting the recorder, it's about 4 frames per second. Then I need to change the USB configuration, reduce it, and then I can go up to like 10, 12. And if I start turning on compression or anything like that, the driver just dies or becomes unstable. So maybe I'm doing it too fast, and it's like in the process of uploading to the camera. It's kind of not I don't really understand how Indeed does that. They should be more protective from that. I don't know.
I think it's a sequencing problem.
Yeah, could
be. Because if you think of Ecos from CarStars, they have an option that you can reduce or that you can control the USB traffic. And if it is set too low, so that the traffic on the USB 3 port to the camera is too high, then the driver can break down. But
Yeah,
this
so
is a known issue for a long time, and they seem that they can't fix it. I think it's a problem with the libUSB 1.
really,
Yeah.
I kind of doubt it. I see USB devices that are utilizing all the bandwidth. But
yes, but if the USB bus is very busy by doing other things with other hardware, this can affect transfer the traffic to the camera. And this is based on if you use a USB 2 on a USB 3 port and vice versa. And it depends on how you plug it into the Pi4.
Got it. So one of the warnings that the camera speed, actually the driver, is that the firmware that we have is actually trying like a experiment feature, right? And I think
was
that
my
can cause
decision
also
to rewrite the firmware within Rust and make it clean.
Yeah. So I think that can be another issue. So anyway, we will figure it out. Right, the idea to support again Indy is because it's very close to ROS 2 and understand the protocol, and then it also has a recorder that again I tested, it's working fine, right? We just need to ensure that it's stable. If it's stable, we can use it. If not, we'll go our own way, right? Which we will do anyway in the future. It's just good to learn how the camera behaves at this point, because it's not straightforward. Besides that, I already created a ROS2 Node.js for GPS signal. I call this piece timepiece because this is the component that will do the clock synchronization. What I have right now, still in the progress, I will release it probably this week, if not next. So it's on the NIX OS right now, so it's on the Pi4, works with the GPS. The Pi4 will also have NTP server, and that will update the local time of that machine. So all the other machines, when they synchronize with the NTP clock, will become a real-time, close to real-time system with the time clock synchronization.
My experience with the uBlock 7 is that the timing can be as accurate up to 3 nanoseconds, and it loses at best, if you run it the whole month, about 12 to 15 milliseconds. This was the worst, and the best was around 70 nanoseconds. So it is very, very accurate then with the uBlock 7 GPS dongle.
Perfect. So given that I have like, I don't know, like 20 hertz should be enough.
Yeah.
Also, it's publishing the GPS data on ROS 2.
Yeah. So we just need one and can use it later for the PTF. Because
And
for the positioning, we need that accuracy. For the camera timestamp, it's not that crucial.
Yeah, and on top of that, I was trying at first to be like a smart test, but I gave that up, like to auto detect the USB device that is GPS. I moved it to do it at a later time. Just went down a rabbit hole. But what I did end up is having the kind of USB device, /D/USB, whatever, be a ROS2 parameter, so we can configure it remotely. And same goes with the baud rate, right? So it's really like just plug the GPS, run the software, and you can configure it remotely.
Cool.
Okay, so that's in the works.
All right.
Kind of work. I still have some issues, but
do you Okay, my question goes direction archive management. Is there anything in play right now that stores something in a file at an event, or stores it in a database or anything anywhere?
No,
No.
not at the moment.
Oh,
no.
okay, okay.
It's on my to-do list. I've been working on some simulation stuff which I can demo to you guys today, now, at some point today, if you want me to.
Go
And
ahead.
then okay. All right, okay. Okay. Just two minutes. I've got to try and remember how to do this now again.
Okay,
right,
you need 2
so-
minutes?
No, I should be okay.
Okay, no worries.
Let me know when you can see my screen, and I'll show you.
Yes.
You see the screen? Okay. Yeah. So I've been just messing about with like synthetic data stuff, and so I've been working on this today a little bit. So I'll just show you what I've got. So currently I've got two options. I can basically generate data for a plane and generate data for a drone. So I'll show you the drone first. It's not terribly clever. All I did was record from a previous video, and I've just got essentially like a track that I've just hard coded, but it should give you an idea. And the goal behind it is to be able to just capture some metrics, and also so you can kind of see the little dot zooting around. So that's a generated dot, just off the track from Brad's drone video. It's the easiest thing I could do, really. But the idea is to be able to record some sort of metrics to do with this, and then evaluate future changes to the tracker so that we ensure it's heading in the right direction versus the wrong direction. But that, so just replays the same track over and over. I still need to do configuration and stuff like that, and I'd like to also go down the routers to try and maybe, put a plane on there or something. But at the moment, I just want to kind of get it up and working and integrate it into the tracker, and just kind of show you guys, really. I'll show Matt once when he's around as well. That's pretty much it.
Hey, Mike, a question. What we see here is this the simulation only, or is there also tracking involved here?
Yeah. So the tracking is real. It's tracking using the tracker. The only simulation is basically this dot that's being drawn on the screen.
So the track, the green lines and the rectangle is
that's
coming from the tracker.
That's the tracker.
No
Yes.
way. No way.
Yeah.
Yeah, come on.
Yeah.
Really?
Yeah.
Wow, this is seamless.
Yeah, I mean, there is some image resizing and stuff like that going on. There's some stuff I need to work out still, but yeah, at the moment, the only simulation is you can see the frame is static, so that just kind of, it just plays the same frame over on a timer. So basically, it's over here, and I've got a timer. I've got a timer. So there's about 20 frames a second, and it loads a frame, so I can pick. So if I cancel that, this is all stuff I still want to, improve on. But so So I just grabbed a couple of frames from some videos. But yeah, the only thing that's the simulation part is just the as I say, is just the dot zooting around. Everything else we're just running past the tracking algo. So it works pretty neat, I think, you know. So yeah.
Do you impose this on the original resolution or on the scaled resolution?
So currently the frame is resized. There's some bug here somewhere where if I don't resize it, it doesn't actually draw this window. So currently I resize the window, the frame, and then the path is kind of associated with a specific size frame. So there's some work that I need to do there. It's not by any means complete, but it's a start. I made a start, a little bit of a start on it today, just to get something in play, just so that we can also record. So in theory now, what we should be able to do is we should be able to record how many tracks per frame is happening, and hopefully create some sort of benchmark that we can then compare against. And there's nothing stopping us. There's nothing stopping us essentially. So this is just a single frame that's in a loop, but there's nothing stopping us overlaying this onto a video. Like if there's already a frame, like for example, clouds moving and this sort of thing. So there's quite a bit of work that still needs to be done, but it was just a start, and I just thought I'd kind of demo it to you guys, just because I thought it was quite nifty, really. It tracks it quite well, I think, So
I mean, the background is not moving, and that helps the
No.
tracker, of course. But I have to
course.
say the tracker is incredible.
Yeah, it's not too bad. So it's yeah, I mean, when we deal with bigger frames, it might be a bit more difficult and sticky, and I'll see how it goes. But I just wanted to get something. I just wanted to get something to be able to demo to you guys today. And also, I know David and Matt and I have been back and forth with regards to simulation and so forth and so on. So just thought I'd make a start, really. Anyway, that's pretty much it. So I'll stop sharing and be quiet now. So,
Cool stuff. Great stuff, Michael.
No worries. Sorry, I was trying to.
Oh, very nice.
There we go.
Well done.
Oh, it wasn't too much work, so it's not. Yeah, it's no biggie. Yeah, but thanks. Yeah, I thought it was quite neat. Anyway.
Quite neat. Incredible work, Mike.
And just a question, Mike. What background subtractor is it using, and the blob detection also?
Yeah, so this is so it's the one. So it's using the Sky 360 background subtractor, but not the Sky 360 blob detector, purely because I haven't rebuilt those Docker images yet for the ROS side of things, just because they just take a little while to build. Because I kind of got to build the 5 ROS images and then and then push them up to the Docker Hub and stuff like that. So it just takes a little while to do that. And so yeah, I was gonna try and do that this coming week. So I mean, one thing I have done is I've created like a separate launch file and launch like entry point script and all this sort of stuff. So it's very easy to run the simulator versus a video. To change from the one to the other. It's really easy to do that. It's just run a different bash file. So there is still there's still lots of work there's still work that needs to go into it, but yeah, it's just making a start on it,
And you updated on GitHub's simulation?
So I'll have a chat with Matt as to the best way to do this, because currently it's built into the ROS 2 version of the Simple Tracker as a ROS 2 node. So I mean, I can share my screen again, but essentially what I've done is the launch file. Let me share. I'll show you quickly. Let me know when you can see, and then. Can you guys see my screen?
Yes.
Okay, so I've got two launch files here. So this is the entry point for when we replay a video, and this uses like different nodes, like the camera simulator node, and that to be able to provide the frames of the video to the application, whereas the simulation node doesn't actually use that node. It just uses the synthetic data provider node. So you can see there's no camera node there. So, and then I have there's a launch script here which will basically launch the application using a video, and then the launch simulation script which will launch the application just using the simulation. And the idea is that, to try and make it quite easy to go from the one to the other. Like, for example, I should be able to just very easily just hop over, and now this is essentially just playing the video. So this is just replaying a video and not the simulation. And it's just crashed there. But yeah, so I'm trying to make it as easily accessible as possible. And then I'll, once I've got it working, I'll be in touch with Fabio, and we can get all the Docker images rebuilt and stuff. But it's just trying to make progress in it,
Cool.
Okay, that's pretty much it. Ready?
Thanks, Mike. You see us all baffled.
Yeah, I'm not sure why. So, yeah.
We did, at least me, I didn't expect it to see that quickly. You were speaking about this before Christmas, and now we see it. It's just like.
Oh, okay. Yeah, but
birth.
some of the stuff. Yeah, but because of it's quite. That's the benefit of using something like ROS, because all you do is you just author another node, and that then just feeds into the application. It's really so. It's to do with the platform we use, actually, that provides that sort of speed. It really makes developing that sort of thing quite quick, because you're just swapping one node out for another node, so you don't have to worry about, it's very good in that, because you don't have to worry about the other part of the application. You're just swapping one node out for another, and the application just carries on as it did before. So yeah, that's more a benefit of using, that platform versus my coding ability, to be fair. So, and I just want to move it forward, because I know Matt is quite keen to put some simulations together and metrics, and kind of get a bit serious about evaluating improvements, whether they're heading in the right direction or not. And I completely agree with those views and ideas. So I just want to support that also. And I mean, Dave is also so it's just trying to move it forward really. So
cool. So David, you want to repeat the procedure that Mike did? Did I get that correct?
Great work, Mike. It's really interesting. No, I was just looking at some ways you could evaluate the background subtraction process, because I'm quite familiar with that from the previous Skyhub tracker that we had and the problems that we had. I know you guys are quite far advanced now in looking at different background subtraction algorithms, but one way I thought you could evaluate them is if you do some simulation data like Mike has just shown, and isolate that moving object and generate some frames with just that moving object, and then compare them with some metrics on against the same setup but with a dynamic background. So if you had different cloud formations and different lighting conditions, you could see how robust different background subtraction algorithms are through that way.
Yeah, exactly. So what you say is, I just recall it for myself, is that you want to take, for example, one certain flight movement, a pattern, and compare it to with various background subtraction methods and background material. So to see the spread of what works on what conditions best. Did I get that right?
Yeah, I think there's been quite a lot written about how you can evaluate different algorithms and background subtraction. And on the change detection website, it's got a list of metrics you can use. I think they're all kind of derived from false positives and true positives and all that sort of stuff. But yeah, that's basically the idea. It's just you can, if you have a known moving object and you've got the data for that, you can compare it against different backgrounds and see how well the background subtraction suppresses the moving background and extracts the foreground correctly, if I understand it correctly. I'm still learning about this myself, but yeah, I don't think it would be hard to set up something like that.
Yeah. What goes in line with this discussion about background subtraction is it, Fabio, yesterday we have spoken about it. It's that a background subtractor, no matter which one you choose, is based on a certain amount of frames that are compensated. So let's say a running average background kind of comparison background to the actual frame. So there's always a certain number of frames involved. And the discussion we had yesterday was whether we can test into having a different kind of ROS nodes running different kind of background subtractor. The one going more for slow moving object or slow moving backgrounds, and one going for short time events. The discussion came from the video, the meeting we had yesterday with Tommy. By the way, Tommy, hi. Tommy showed us raw footage, real footage from Skinwalker Ranch, and there was a video where an event happened just in one frame. And yeah, Tommy, you can probably show this event. The discussion on that was then whether our background subtractor would in any way be able to recognize an event that is just for one frame, no matter what size, what shape or light event it will be. So it's just because of that short time, and background subtractor, is, at least as I understand them, always take several frames into the algorithmic composition, and not only one frame. So the idea is to make a separate background subtractor that looks for these short time events, and the other one is the normal background subtractor that runs in parallel. Kind of. That was, yeah. Maybe Tommy, you can show the image so that we all know what we're talking about.
Yeah, keep talking. Just give me a minute. It's taking me a second to pull it up. Just keep talking.
Yeah, then just for clarification, we have several different background subtractors. There are some that just look at the previous frame or the previous 2 frames, for instance.
Yeah.
Okay, and so these are the ones that are very fast because you have a lot less operations to do, but they have some problems, like we were talking about yesterday. For instance, ghosting is like what's happening right now when we try to track things that moves too fast, or they're like separated on the image by a huge amount. So it generates like 2 images because we don't have 2 frames to compare. But they are fast, and they can remove background very, very easily. And so they work for fast moving objects, I think, like this.
Yeah. Okay.
But they generate some sort of artifacts sometimes, like ghosting when the object moves too fast or something like this. And we have the other background subtractors that are good at removing background and generate good output, but they take like maybe 10 frames or 20 frames comparing, and they are slower.
Yeah.
So they have the benefits and the pros and cons that you have to compare to see which one to use, and then you have to figure out.
Yeah. So the thing is that you can't have both. So you can't have one that goes for quick maneuvers as well as very slow ones at the same time.
Yeah, I think so. Mike can say more, but
sure you can. Yeah, you definitely could do that. Yeah, I mean, you could have a separate node that runs, like you could have 2 nodes that run different background subtractors. That's not a problem at all. So, and yeah, so that wouldn't be an issue. And
Mike, look in the chat and you'll see the pictures that we're talking about.
Can you share your screen so that we can all see it, Tommy?
It's in the chat.
Yeah, but
just open your chat.
Okay. I have it on record anyways, but when I open, I do not open it, right?
I got it. Hold on, give me a second. I'll do it.
The thing is, I don't really. I guess it's something we'd need to define is the value of capturing an object that only appears once.
Yes.
That sort of stuff, because that will generate an awful lot of noise, I would have thought, and because I think in my opinion, the thing you want to try and avoid is to reduce the amount of noise that gets generated, because otherwise people will just ignore what's captured in a way,
The problem, Mike, the problem that we have, Mike, the problem that we've got is that not everything is noise. We literally have a situation on our hands where only this stuff that I'm about to show you is being picked up on these cameras right now. I mean, I haven't seen, for example, I have a CCTV set up. I live on a lake, and so I have the same kind of view, horizon view that you're seeing here. I have no trees. I have nothing to worry about. I can see the sky from left to right as far as I want to see it. And I've got CCTV cameras that are constantly filming the lake, including the sky. And I don't have any anomalies like this that come up. I look for this stuff because I'm trying to compare their CCTV cameras and mine, or just anyone on the market. And I've got the latest and greatest 4K version, just like they do. Mine are IR, just like they are. But I don't get glitches like this. So what you're seeing right now on the screen, that's one of them. Here's another one. What you're seeing is, as you're watching the video, all of a sudden, out of nowhere, you get this blip. And this lasts for literally less than a second. Just enough for your eyes to catch it.
One frame.
Yeah. So you go back and you stop the frame, and this is what you get. So the question is, are these anomalies that the cameras are picking up? Are they all glitches? Now, It's hard to believe that the camera. Look, if I go out and spend $1,000 per camera, by God, it better not be coming up with glitches like this. Otherwise, I'm going to go back to the manufacturer and raise hell. So that's my point: is that the production, the consumer market is not going to allow you to put out cameras that puts off anomalies like this, especially if it's sporadic like that. So if you could show me some examples where this stuff is going on, then okay, maybe we don't need to capture it. But in my eyes, we need to capture stuff like this somehow.
I would say this looks. I've seen the video you showed me before. I would say these moving objects, they are too fast for normal cameras to catch them. So one possibility is to try out a high-speed camera with, let's say, 20 megapixels, but they are hard to come by because they are very, very expensive. I've used high-speed cameras 2 years ago, and they could just provide up to 200 frames per second with just VGA resolution, 640 by 480. But if you want to have that with a 20 megapixel camera, such a camera would cost around, for buying, around $100,000. And this is impossible to get. Maybe for the purpose on Skinwalker Ranch, it could be done, but for normal people, it's out of a question to use that. And what we can do with the QHY 183C camera is at best, let's say, 20 frames per second with 3600 by 3600 pixel in 16-bit color depth. And this is the problem. We have got a huge number of data that has to be processed. And can we put that amount of data through USB 3 with the right frame rate? This is a question. It's not a high-speed camera with high resolution. And I think if we can manage to have such a camera out there, high resolution, high speed, high color depth, yes, we can maybe, in retrospect, slow such an event down and see it not very blurred by motion.
Yeah. The other thing to point out is that this isn't happening every day. This is the first. Actually, this is the first time they've caught this. It just happens to be, I guess, 2 days that they caught. The one spot that you see on the monitor right now is 1 day, and then this is another day. So you have two different types of anomalies that the camera is depicting, whether it's a glitch in the camera or not. Just the point is that that's what it's depicting.
Yes. Sorry, Tommy. I didn't mean any disrespect with regards to the term noise. I didn't mean there was a fault with the camera or anything like that. It wasn't meant in that way. It was just all I was trying to get across is that it's just going to be a challenge. I think if you to try and differentiate, like if you have an object that appears on one frame and not the next one, you're going to have a lot of those, to work through. So sorry. So I didn't mean any. I didn't mean it.
No, I understand where you're coming from. In my opinion, though, we need that data, no matter what that data is, in order to rule out what perceptions. Because right now, I shit you not. I'm sorry, I shouldn't have cussed. I kid you not. I sat with 20 ladies in a room that are convinced that the image that you see on the screen right now is a possible portal opening up.
Yeah.
So the only way you can prove that, the only way you can prove that is to capture this more than once. So that you can prove that it is either a camera anomaly or something else. And that's why you need to capture the noise.
I think it's going to come down to just storing vast amounts of data and those sorts of things. I think technically you can store it. It's just It's just where do you store it, and the costs involved, and those sorts of things. So yeah, I mean, I think that's going to be your challenge.
I'm saying from the very beginning, once you establish, this could be a couple of days, it could be a month. Just the point is that once you have a couple of these, you can then say, okay, more than likely, more than 75%, this is a camera glitch of some sort, whether that is processor, whatever. Just the point is that we can rule out that it's not a portal. That's the point. And then you can stop looking for that stuff. Just the point is that if you go start building things to remove things, that's going to be a problem for us.
I think you see it all from your perspective, and I get it. But I think it's much more easier answered. First of all, we know these are very short time events, 1-2 frames only, right? We will never be able to track it. Okay, so even the delay between one entity telling the other entity device inside a station, even if it's ROS2 and real time, this delay will not be able to produce anything that we can track.
That's a good point.
I think it's not a question of tracking. It's not a question of what we normally think of a Sky360 station doing. Okay, so what I was asking for the background subtractor to be able to run on short time events, on very quick events that only last for 1 or 2 frames, is so that we can have a node that we can tweak. So we can, for example, simulate such events very easily. We have just an example right now, and see how we can trigger such an event as not to be recognized by this special node as an event that has to be carried on and tracked by other devices and what have you, but only as a local, there's something strange image, and stores that image and keeps it in a certain folder just for research. Nothing to do with the normal procedure or purpose of the station. I think I see this as a special experiment, let's say. And maybe we find out that this is not only a nice experiment, and we find out probably that there's a glitch in the camera, but maybe we find out that, interestingly, many cameras produce such events, and they look maybe similar, or they happen at the same time, or they are in a certain direction. Maybe there's a pattern in it. The point is, Tommy, we have no means at the moment to give any answer, and I think because of that we have to either do this experiment, and I would say for now it has nothing to do with Sky360 and our focus on the alpha version. Yeah, this is something that we can experiment with and put on into the image finally, and have test runs on several stations and just create data and see whether there are patterns.
I don't want to
do this on an observation.
I don't want to change the course of the Alpha 1. I'm just saying in general, this really needs to be considered. If we're not going to do it, we're not going to do it. It's not an issue. I just think that it's important to capture as much data as possible, even if it's a glitch, so you can rule it out one way or the other.
I want to say, I'm not a video expert or a camera expert, but the higher frames per second would help you to track the object in the sky, right? I mean, if we had enough frames per second coming in, we would actually be able to see it go through the sky.
Yeah, it's not so much receiving. It's not so much. It's processing power. That's all you're going to be constrained by. Is just if you want to try and run something that runs at 100 frames a second, you're going to need a lot more hardware than we are currently suggesting, sort of thing. Right. So I think it's just you can do it, but they're going to be constraints that you have to work within, and those will just get exponentially more expensive and stuff like that. So it's just that sort of thing.
We can even, if Rebecca as an answer to you, I think it's basically it's a great idea to have something on very high speed. Let's say one station that is the monster, for example, that runs on 1,000 frames per second. I don't know, just an idea.
Good idea.
And put this only one station. Let's say we find a funding for this so that we can build it. And the focus is not to multiply it. It's just one experiment station that does the weirdest things, and put it on a place where there is custody, that there is someone who provides it, maintains it, powers it, cable, network, and so forth. And
he is not going to say thank you for getting it.
Right. And gives it back afterwards. So something like this.
I have something to say about that. We make a high-speed broadcast camera. It shoots either 240 frames or 500 frames, and it outputs SDI 1080p 60. And so that's one of the cameras that I'll be sending out to the ranch to point in this direction, like you're seeing right now, the southeast direction. And the only thing that I'm working on right now is just working on the capability, so I can record to like a monitor with a DVR, but the DVR has to have a large enough SSD drive to capture that much video, because it's a lot of data. And the problem is that I could let it sit there and run 24/7, but you can imagine you're talking about several mini gigs of data that it's capturing. So that's what I'm working through right now, is trying to set up a system that will allow them to record the raw data off the camera, and then let them figure out what they want to do as far as streaming that back live for people to watch, because that's what they're doing right now. They record everything raw data to hard drive, and then they stream it out from there for a live view, if you will, on YouTube for people to just sit there and watch it.
Would it be possible to just create image sequences and not convert it to a video?
Possibly. I could. Yeah, absolutely. I think that could be possible by through the software, and I could put you in touch with our software engineer that does all the custom work, basically. And maybe you guys can work something out like that.
Yeah, I think it would speed up the data transfer a lot if you just push out images that are put into a video sequence afterwards. So maybe the frame rate could be increased to double. So 1,000 frames per second.
Right now,
it depends on the exposure time, if you can do that with CCTV camera.
Yeah. Well, this isn't CCTV. This is an actual CMOS, Sony CMOS IMX chip.
Okay. Then it's possible to do that. Yeah. I think it's 1 millisecond.
No, it's possible. It's possible. It's just a matter of getting the guys to do it. That's the trick. Because right now they're overwhelmed with other camera builds right now.
Hey guys, what about a simpler idea? To increase FPS, and if you have a system, let's say, that runs 20 FPS, and we have the lower version on it, let's say by end of March, we can say we can build one system with the camera and the Pi and what have you. So, and then say, okay, this runs on 20 frames per second. And then say, okay, we multiply inside the station. So we put in 10 systems, 10 cameras, 10 fisheyes, with 10 Pis, and always by 10. And then via timing, and that's the question to you, Ido, you see this feasible, then via timing, start the tracker and coordinate the timestamps, so to shift every camera by, let's say, 1 frame, so that we increase, let's say, the 20 frames per second to 200 frames per second.
So, okay, when you capture a frame from the camera, you don't control the time it's taken. So in order to synchronize the clock across all CMOS chips, you actually need to do exactly that in hardware. So very similar
to TTL signal that does it, yes.
There is what? I'm sorry?
You need a TTL signal to do that, to synchronize. And this has to be a lot faster than the cameras can handle it.
Yes. Very similar to what the Kraken is doing, right? It's not a straightforward solution, specifically if the station are farther from each other.
No, I was just talking about one station and we multiply the system interior. In opposition to a monster.
Yeah, you will need to get the bus to the sync clock bus to support.
Of course. Yeah, but you know they already stack Raspberry Pis, so why not?
Yes, I know.
Why not stack a Pi5?
Well, they are stacking the Raspberry Pi. The Raspberry Pi is actually designed to be stacked now, like the new boards.
Yeah.
So it's
yeah.
But hey, the Pi5 has NVMe, so.
Yeah, okay. So could we make a special? We're just fantasizing here. It has nothing to do with QHY 60, our normal development and our goal. But let's say for a special purpose, let's say for the Skinwalker Ranch purpose, we create a monster machine that incorporates 10 stacked Pis with 10 cameras. You see any feasibility here, Ido, to have a good timing on the acquirement of the image, to say exactly on I don't know, on the millisecond when you acquire an image from the camera. So in order to control the incoming process, the rest of the process is uncontrollable, of course, but at least we can control the acquisition of the image.
So I can see that working. But you know, the best will be if you design your own camera, so you have access to the time clock and you can actually configure it. This will be very hacky. Like if I need to do it on the QHY 1A3, I need to like reverse engineer it, figure out where is the clock and tap into it. And that's messy.
That's what I'm doing at the moment. Writing
Good to
new
know.
firmware that will achieve that. So we have to address everything that's on there, and this is what's taking time.
Yeah.
But we will succeed in that because we already know what we are doing, what we are looking for. And the API of the software development kit from QHY helps, but it's tricky. And rewriting it in a programming language that has so much speed up because it's using functionality, that helped a lot. I was at the point around 2014 doing the same without Rust, but with Python. And now with the development of Rust, at the time around 2014, Rust was very new on the market. But now it is so much more capable of things that we can do it in Rust in the firmware, and our speed up will around 50%. This is a lot. So yes, we can do it. We can have that, but it's taking time.
So the thing we were talking before, Christian, the so-called monster machine for Skinwalker Ranch, do you see a feasibility here to have a good timing for the acquisition of each frame from 10 cameras?
With the QHY cameras, no, because they are made for something else. They are made for high resolution in everything, in dimension as well as in color depth, but not high resolution in frame rate. For frame rate stuff, we need, I would say, other cameras that are produced that do have the speed up in hardware. but that is not my expertise. So I once used a Sony camera, I think it was, that was capable of doing 4,000 frames a second, but only with 640 by 480. And this is not feasible for us.
Now, first of all, that's why I put up the alternative, not to make a monster just to blow it up and have more frames per second and therefore more process power and so forth, more costs and blah, blah, blah. But to have an alternative and say, okay, we are on a 20 megapixel, 20 frames per second level, let's multiply that timely. And
we can't. Because we have to, we would have to synchronize it, and this is much more complicated than having a camera that does it serially.
Would it be? Yeah, okay. Would it be? Would the camera with the QHY, the 183, would it be able to call it within a millisecond? The acquisition, say, give me an image now.
Yeah. Millisecond is no problem, but you have to go beyond that. 10,000 frames per second, or 100,000 frames per second.
Come on, let's start with 200 frames per second, just to be in the realistic world. I mean, you don't get cameras with 100,000 frames per second.
No, you will not, because the camera is trying to capture a frame as soon as it transmitted the previous one, right? That's the experiment feature that I spoke with before earlier.
Mm-hmm.
So you don't have control on the timing for that.
Mm-hmm. Okay.
If we can try to patch the firmware and to tell it, hey, start capturing now, we might be able, but it's not going to be a millisecond accuracy.
Uh-huh. Okay.
Not without like a proper hardware time clock bus. I don't see that.
Even when you are master of the firmware, because you did it yourself in Rust. Not even then.
Well, I will have to do it anyway. I will need to be the master of the firmware anyway.
But even then, you say it's not possible because of hardware limitations.
Yeah, it's difficult to achieve that. But
so think about it this way, right? Time clock synchronization means that all the chips are getting the same ports from the same kind of crystal, right?
Yes.
But what we want to do here, we want to create, like, let's say, a 10 milliseconds delay between each one, right? So they're alternating, right? Yeah. Hardware. It's a hardware problem.
Yes, of course. But any idea that it is feasible, that it is possible?
Oh, yeah, it is possible.
Depends on
Point
your
of
budget, I
information.
suspect.
Michael, go ahead.
Yeah, I was going to say a lot of cameras do have provisions for external sync, and so what happens, that sync pulse comes along, and usually used to start and stop them, and usually you're going to run more than, say, a frame. But it seems like using that feature to just do a start stop, and by, how do I want to put this? I got two cameras sitting here, or three or four, right? I go sync here, right, and I got some, Pi or whatever it is back here. It trips this one, and then 10 or 15 milliseconds, however far down, it now trips this one, and the camera firmware would be set up so that when it sees that sync pulse, it's just going to grab one frame, and that way that will allow you to step down an arbitrary number of cameras. And I think that would be feasible with the kind of thing that's not insanely over the top on price.
But in that case, you have one board. So when you have one board and you capture with not 20 frames but 20 frames per second, you have to have 10 times more power on the board, which makes the board more expensive.
Yeah, but if you're just generating, sync pulses, though, something to trip the camera to actually, just grab a frame for you.
For the sync only, yes. But then anyways, you need...
That shouldn't be that.
Okay.
That's just the point. Is there might be a way to do it, but I wouldn't want to take it on right this moment, because again, it's get the alpha, out and working, and kind of the same thing for trying to capture these very fast transient events. I see the value in it, but given that right now we're just trying to make it so it tracks accurately, then it to me it's a secondary kind of thing, for the moment. Now, as we go forward, we get trackers deployed, and we say, oh, we are or aren't capturing these kind of things, then maybe work out a way to do that, or or ignore it, or whatever has to happen. But that'd just kind of be my take on it. But I think it's possible to do a series of cameras, fairly inexpensively, that you say, okay, camera 1 now, camera 2, camera 3, camera 4, and because you're only going to grab like a frame or two from them, then the recovery time for the imager and everything else, is essentially irrelevant, because you're only grabbing a frame, and so on. So again, just an idea there, and I think it's feasible. But again, I'd put it out there like version 2 or 3. I wouldn't pursue it too hard right now unless somebody's got the spare time to do it. Just as again, it's just a thinking out loud, because like in professional movie and video cameras, okay, the industry standard used to, I don't know if it still is, I haven't been playing out there lately, but it used to be something called SMPTE time code, and that was a way of syncing up everybody. And there's gen lock is the other term they use to keep all the cameras synced up. But you can use that same facility to go in there and just say, oh, just do this real quick, And so a lot of this stuff to do it exists already, is the point. And it's just I wouldn't be pursuing it right this minute.
Yeah,
just
absolutely.
my 2 cents worth.
Absolutely, you're absolutely right, Michael. It was not my intention to kick anything anywhere in any direction here. It came up yesterday, and I thought it fits to the discussion of background subtraction in the first place. So, but yes, I think it's still a good idea to have a kind of a monster machine that does 10 times the work of one station. Let's do it somewhere in the future. So, Tommy, somewhere in the future, maybe
Custom
every
job.
year comes up a monster. I wanted.
You mean a Bigfoot?
Pardon
You mean
me?
a Bigfoot? I don't know what it is.
Yeah, we simulate Bigfoot videos, absolutely.
Oh, I like the name Sky 360 Bigfoot.
No problem. I'll be happy to sponsor that right out my back door here. No sweat. Because there's still weird stuff going on up there. I can't say it's Sasquatch, but there's oddities. So.
You guys can tell me if
You'll need
I
a
can-
Bigfoot generator also.
Hey, Michael, you need additional camera for Sasquatch. Additional station.
Well, actually, I'm working on more or less the equivalent of that. But basically, the plot is to use the tracking stuff from Sky 360 to tell those cameras to be looking at their data and say, oh, we have some event or we don't. See, so I'm plotting some alternative uses, but again,
Yeah.
I don't want to let them sidetrack me from getting this happening.
No, we
So,
need to
that's
encourage
what I'm
you.
saying.
We want to encourage you. Don't worry.
I
Yeah.
knew that
Well,
would
well, the
happen.
thing is, okay, I'll bet everybody on this call right now, okay, knows of some project somewhere that has died due to feature creep. And so I'm trying, there's some things I've heard I love it, and some things I've come across that, hey, I want to put this in, but not this instant, okay? And the biggest one is, God, who came up with the whole modular thing, okay? The modular sections for the tracker build. It's off on one of the things there. But anyway, love the idea. Okay, because he said, oh, we got a main processor with the all sky camera on. We got one for the tracker and blah 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 blah. And you stick them all together, and I love it. I really do. The catch is, okay, you wander off down that path, and you'll never get back to, oh, hey, where's our alpha? So that's the
No, we're not.
So that's why I want to.
We're not skipping
How
alpha here.
Yeah, well, you understand. Yeah.
How cool would it be that
Well,
we're
like I
the
said-
first one Sky 360 captures a UFO and Bigfoot? I'm sorry. That's going to be the headliner right there.
Yeah, I
Bigfoot
will.
got the
Okay,
Bigfoot.
if we can convince Bigfoot to set his foot into a flying saucer and will wave his hand by flying over a Sky 360 station,
Yeah.
I think then we did it. Yeah.
Yeah,
Well,
stop
I don't know if you
meditating.
guys are aware of this, Well, I don't know if you guys are aware of this, but the UFO people do a lot of the categorizations and things for like entities seen in conjunction with UFOs. They do have a Sasquatch type creature defined in that, and they are seen and found in that block of research. So that may not be so far fetched as a lot of people want to think. Just as a, again, just a side note. So there may be more going on there than is well known.
But wasn't that a Wookiee?
Well, call it what you want.
He already has a name. Chewbacca.
Chewbacca.
Well, if I see Chewbacca, I'll wave to him as I'm running like hell.
Yeah.
Yeah, this is the typical human fight or flight. Fight or flight.
Right.
Yeah, anyhow. I wanted to come back to the discussion that Mike initiated with the simulation. Would it make sense? I can recall what Yannick, you have shown us before Christmas, and I recall, right, your probability measurements go in line with what you read from the results of Simple Tracker, right?
Sorry, I was distracted for a moment.
Bad boy. I'm making
Sorry
a
about it.
So, we were talking before with Mike about simulation, and I assume you have seen the simulation of Mike, the simulator, right?
Yes.
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 I recall what you've shown us before Christmas, your kinematics classifier with the probability rate and the tracker based on the output of the Simple Tracker, right?
Yes.
Okay.
Yes.
What
That's
if
correct.
we marry these two?
Yeah, I think that's the goal, right? So, if we want to include the kinematics approach, I always thought that it will be included in the Simple Tracker code.
Yes. Yes.
Yeah.
I just need to do it. It's on the list.
Okay. Okay. Sorry.
This ever-expanding list with super PCs that are with 10 cameras and all this sort of stuff, and it's on the list.
Okay, I see you not coming anymore because there's too much pressure on you with too many ideas.
Just start a backlog. That's the best
That's okay.
option.
I can only do what I can do, to be fair.
No, actually, Mike, I wasn't thinking of you. I thought that Mike can if you commit your code, Yannick can then add his code into yours. That was
Of
my
course.
thinking.
Yeah, I would think. I mean, I'm not very good at object-oriented programming, so that's not what I do in my everyday job. So I always thought it might be better if Mike takes my
okay.
code. It's not too many lines, I guess,
Yes.
and he can include it in his Simple Tracker if that works for him.
Whenever
Just
you
don't
start.
use
Where you
objects.
Yeah, that's
Sorry?
fine too. That's fine.
Don't use objects. Don't use
I don't
inheritance.
get that.
That's the best advice
Oh,
I
no.
can give you.
No, that's
Okay,
fighting
so-
talk, that is.
Don't use objects.
Well, I'm used to Fortran and MATLAB and
Objective-C.
that's where I'm coming from. So
Got it.
Fortran doesn't even know object-oriented programming. So yeah.
Well, you see.
What?
You see.
Yeah. I don't know what you mean. Sorry.
Use the C
C
functions
language.
and
Oh,
structs.
okay. I see.
That's it.
Yeah.
Yeah,
I can try.
Functions,
So-
structs, and pointers. That's it.
I know it's faster.
I think some of us have lives as well outside of this.
Yeah, that's
that we would
true.
like to
Really,
experience.
do you?
Exactly. We do.
You've forgotten too, right?
What is this? Some new is this some new fad I haven't been advised of?
So write it in Fortran. Actually, I have another idea. Write it in Fortran.
Let's not talk about Fortran, please.
No, ask
it's gonna be awful.
Ask ChatGPT to convert it to whatever language you want after.
Huh.
Yeah, that's a good idea.
That's
actually,
a fun idea.
We should do that.
And it works, okay?
It works.
No, I did it. I got some code. I put it there and asked it to just convert it to C++, and it did. So
yeah, it does that. Very good, actually.
Sometimes it has some small bugs you have to fix, but it's easy if you know you spot it and just fix it. Or you can just say to ChatGPT, okay, this place is we have this error, and it will fix it. It's amazing.
Yeah.
So
by the way, another option.
Sorry, if you have any questions around the kinematics approach, I can do that now in 1-2 minutes, or otherwise I have to move on. So
go ahead.
Yeah, I mean, I don't know if you have any questions regarding that. I wrote everything I did so far. I wrote in the neural network channel. So, the basics was. Yes, I also uploaded it into GitHub. So, Lionel, if you want to take a look at that, at the code and everything, it's everything there.
So kinematics, and so it's all the notebooks are there. Okay.
Yeah, there's a notebook. There's some Python code, and it should be everything that you need, I think, to test it and work with it.
Yeah.
If not, you can notify me any time. So.
Hey, maybe Lionel, when you can make it run on your computer, maybe you can put it into Mike's work, add it to the simulator.
Yeah, that's what I've been doing this week. I managed to boot the ROS2 environment with Mike's simple tracker.
Mm-hmm.
So it works on my machine now, and
cool.
I follow the training on ROS, so I should be able to put together some module.
Okay, yeah, that would be great. Yeah.
Nice. Richard, another way to achieve the Bigfoot machine. It's actually using a PPS signal from GPS.
Yeah.
Okay. I have to move on. See you.
Okay, Yannick. Thank you.
See you next time.
Yeah. Bye. So anyway, if you use PPS signal from GPS, you get like time accuracy of picoseconds.
Mm-hmm.
And but that will require you to move away from like Linux more to like real-time operating system. And then that's achievable.
Yes, but we are just talking about this hypothesis and this idea only, okay?
Yeah. I'm just
development.
my brain is working.
Yeah, okay. Just for listeners or some people come in new here. I was not talking about, let's say, 1,000 frames per second. I was just talking about 200 frames per second. And this is just a half millisecond between each frame, right?
Mm-hmm.
So, if we have 0.5 milliseconds, and you call 10 cameras every 0.5 millisecond another one, that would, if code and processors are all the same, and yeah, maybe they are not, that would result in about the same order of results coming in. No?
So again, to achieve that without a proper clock on the hardware, you have to go real-time OS on the operating system with a high accuracy clock like a PPS signal from GPS. That's another option.
Yes. But okay, that I was referring to what you said, and you were talking about the picoseconds, and I was referring to.
No, I'm just telling you that's how PPS works,
Yeah,
right?
yeah.
It can give you.
Yeah, the PPS signal. I know, yeah.
Yeah.
But of course, you can read the PPS signal on a pico level, but you do not call the images.
But I cannot. No, I cannot. The problem is I cannot guarantee the time execution on a non-real-time operating system.
Yes, absolutely. The only thing we can say
Right.
is the initiation is at a certain time, but we do not know what happens afterwards. Okay.
Yeah, we can do that with ROS2 to a very accuracy, but to a sub-millisecond probably not.
Okay.
Without a real-time operating system. Okay.
But if
ROS2 will tell you if you violated your time constraints, so we can test and know.
Okay. But at the end, when it's all running on NTP, and we have, let's say, 10 nodes running on NTP, there's a sync, with some delay, with some runaway. I know that, but I think we can achieve, let's say, below the millisecond time evenness, right? So 0.5 seconds, 0.5 milliseconds sync accuracy would be able via NTP, right?
Yes.
Okay. So in that case, I could say from a central node like Michael proposed with a GPS, so that we have the PPS signal. We can say, I call this, I call this, I call this. I call 10 nodes in 0.5 milliseconds delay that I can be sure of because of the PPS signal. That's what you say, right?
So again, in theory, yes. Okay. But because it's not a real-time operating system, the operating system doesn't guarantee the time execution.
Yeah, right? on the node, the time execution on the node.
Yes.
But what we can do is we can say, we called you at timestamp whatever on half millisecond accuracy. We called you and you deliver your work, and we hope you are someone in range, timely, so that normally you should be able to process 20 frames per second, basically. So to call you every 10 times, every 5 frames should be possible for that node. It should not stall. That's what I say, right? Because it normally, when it runs alone, it runs with 20 frames per second. And if you call it every 5 milliseconds, then it runs on 20 frames per second.
Not sure I follow what you mean.
Okay, how can you synchronize that?
By what Ido just said with a PPS signal, for example. You have a central node that has a GPS with a PPS signal. So it has a very accurate time. It provides an NTP for the rest of the 10s. The 10 nodes that have a camera, is a Pi, processes the image, delivers an image. Makes the tracking, for example, or finds out an event. I don't know where we end here.
But again, how one computer is going to speak with another? Through Ethernet, right?
Yes, I see where you get. You're never on real time. I know that. You cannot expect when you call something that you get it back in time. You will always get it back somewhere. You cannot control when you get it back.
So I can tell you if you violated your real-time constraints.
Yes.
But I cannot tell you I can guarantee to do that within a sub-millisecond.
Exactly. But
I can tell you that I violated it.
But what we know is that every node runs on NTP. So let's assume everyone runs on the same time. So when it gets a call, that call has also a local time on the board, which is a global time, right? So
close to a global time. I will tell you, it's plus the ROS2 time that actually tells you the shifts that happen on that node.
Yes.
Right.
Okay.
So
even can compensate for that.
Yeah. So ROS2 already has that.
Okay. So and then starts the processing, and the processing is uncontrollable and will end somewhere. But the timestamp when it ends is again the timestamp of the global timestamp. So it's actually
accurate.
It's accurate timestamp, exactly. And then you got all these 10 feeds in permanently. The
Yes.
events, the results, not the processing. The processing
yes.
is done.
I can order the images.
Yes.
Okay.
Yes.
Of 10 cameras.
Yes.
I cannot guarantee the time deliveries, but I can
Yes.
observe it.
But every image has a timestamp, which is a global one, which is a correct one. So each result has a timestamp,
Yes.
which is a correct timestamp, even if it's
Yes.
not delivered in time or delayed, let's say. Okay, but it
Yes.
has a timestamp, and we know when it was called and what the processing was based upon. We can be almost sure that the processing, no matter how long it takes, runs on the correct image from the correct timing.
Yeah, that's ordering.
Exactly, and that's all what we need. So we get a result with the correct timestamp from when it was called, not when it was processed somewhere and delayed. When we then collect all the data together, of course they will not be all aligned, so we have to realign them. These events that come in from this 10 nodes processing.
A stupid question. GPS data including time? What kind of time? What kind of time stamps? Universal time?
Yeah, it's a UTC time format, but it's just the satellite system's time.
Yeah, it's a UTC time, and there is also dilation that you need if you want to speak NTP, right? Because NTP on Earth has different dilation on it compared to the GPS signal.
Oh.
Okay, let me continue work on the time clock because this is a rabbit hole. Okay. It's a big rabbit hole. It's not an easy one.
Yes, of course. We're just hypothesizing here, and this is only a discussion. It's only.
But again, ordering you can do, okay, but it will not give you the high frame rate that you're thinking of. That's important to understand.
We can after the alpha version is out. We're not talking about now. So somewhere in the future, we can make a test. Let's say we couple several packages of camera with Pis together, and then start with timing. Let's say we start with 2, with 5, and see where we end. That would be an idea, wouldn't it? And by this, maybe we can optimize it and really make out a high frame rate monster version or higher frame rate. Okay.
But you're making it a scaling problem, so that's good.
Yeah, okay. We just have to deal with the scaling problem. I get that, but basically this is.
What was that last question you said? I didn't hear it.
My question?
No, I did. I thought I heard Richard ask a question about high speed. Were you making a comment or were you asking a question? Just a second ago.
Okay.
Before I interrupt.
Okay. But what did I say about?
That's why I didn't understand what you said. That's why I said, "What did you say?"
Okay.
If you didn't understand it either, we're good. Let's keep going. No worries.
No, the thing is, I do understand what Ido is concerned of, and that's the typical scaling problem. But yes, that's also in itself in scaling. You start small, and you don't start with 1,000 times whatever. Right. You do not increase your problems by yourself unnecessarily.
That's why I want to try my camera, because you can start with 200 and work your way up. I don't think you're going to be able to go smaller than 200. If you were to go look at a Sony production camera right now, it goes up to 120, just like your cell phones do. So I think that's the best you're going to find is whatever a cell phone's working with right now.
Then we have the issue of the board, the processing board. When you increase on the camera,
you will have it anyway.
No, why? When I have 10 nodes, I have 10 decentralized processors.
And how you're going to do a simple tracker across 10x frames?
We need a fast blobber that takes all these events.
A supercomputer.
Yeah, one node has to be a little bigger node, but not that big as if you have all in one board. No?
Oh, again, you want to be able to scale the parallelism of your tracker also across multiple compute power.
Yeah.
Right?
Right.
That's exactly what a neural network does. Right?
Okay.
So you need to build a compute that has a neural network that allows you to put like blades on it, similar to what the Pi4 starts doing, where they provide those boards that you can just put on a bus, and you extend your power.
Yeah, stacking.
I don't think they make small enough motherboards like that to do that. The only ones I've seen so far are only allow one PCI slot.
No, I can show you. There are some good YouTube videos that some of them are using like four PCI Express bus. Some of them are using more. The chip has
what kind of computer?
On the Raspberry Pi 4.
Wow. Okay, I'll look it up.
Yeah, they're probably doing like time sharing on the PCI Express. Dividing 1 to 4. Right. But again, the chip has multiple PCI Express channels, right? It's just about building a custom board to support that, take them out, and then plug into them. I think, vision-wise, using the PCI Express as a bus will probably be the best way for us to achieve the bandwidth that we need, given all the high quality of image that we are going after.
Yeah, agreed.
Right?
Okay.
So the question is, can we get an Orange? Oh, you're thinking the Raspberry Pi would take the place of just the graphics, whereas the Orange Pi is going to do all the other.
I'm just giving an example. Like the Orange Pi has also the same thing. If you want to go again, Bigfoot, right? Look at the latest AMD CPU. That's like a $7,000 CPU, desktop CPU. With what it has like how many 80 cores or whatever, and it has 128 PCI Express 4 channels.
Okay,
just build the board for it and then you have it.
Yeah.
Right, and the addition of PCI Express channel is that you get the time clock also.
Mm-hmm.
Yeah, I have the early version of those AMD Threadrippers right behind me, and they work like a charm. But they're not particularly the kind of thing I build into a tracker, just because of size, size and power requirements.
Mm.
So, just side note there.
But by the way, Christian, how complex will it be to take apart QHY 183 and move it from USB to PCI Express bus?
Don't know. I haven't opened it yet because it's not mine. It's a loan from Sky360.
Yeah.
Why not talk about it?
But it broke. I heard it broke.
I mean, you don't break it. You can open it.
Yeah, but opening it loses the guarantees,
Yeah, okay,
and
but it's a development device. I would not expect you to destroy it.
Yeah.
Can you say that it works afterwards?
Yeah. I can take care of that. Okay. Yeah, but I haven't considered it now, and I would ask in our management group to do that first.
Okay. But technically, let's talk about it. I mean.
But then I wouldn't go for PCI Express and would go more for 12G SDI.
Oh yeah, that's actually true. Because then that was SGI support a 16-bit?
No, I think so.
I'm not so sure.
We have to look it up, and we'll see then.
Yeah, true. Because then we move everything to a hardware problem rather than software.
What kind of interface is that?
It's a video interface.
What?
It's a video interface for I forgot.
For broadcasting cameras.
For broadcasting, yeah.
Oh.
SDI stands for Serial Digital Interface. It's for broadcast only. It's the highest quality image resolution you could get right now on cameras.
And I think it's not color depth related.
I didn't understand your question though, Christian. You said we needed to get a 12 gig SDI camera. Is that what you were saying? The output, the resolution output?
No, we're not going for the camera, but we might modify the QHY camera to use instead of USB 3 the 12G SDI bus for transferring image data.
I didn't realize it had one on it. It does?
It doesn't.
It would be our modification to it.
Oh.
But it's a hardware modification.
Yes.
So you're gonna convert USB to this interface, or
no, replace it.
Yeah.
Oh.
Not converting. Converting, then you've got the bottleneck again, and you don't want to have that.
So let me say something because I got experience with this. In case others don't. The SDI, I can tell you right now, is a secret sauce when it comes to creating your video stream out of these cameras. It's not like Sony sends a driver along and it just outputs. There literally is a secret sauce that has to be built to create your image, and that's what my guys do all day long. And so, yeah, that's the only problem I see, because I've got 5 guys dedicated to a team. That's all they do, is they focus on just making sure that image stays the best quality that we can get out on the market. And the GUI interface. Oh, I'm going to ask them. I actually already sent them a QHY a couple months back in October when I first got them, for them to evaluate and for us to talk later about it. So I'll certainly reach out and ask them.
So, but what you just proposed, Christian, implies that the hardware will be changed.
It has to. The thing is, the QHY cameras are made for amateur and semi-professional astronomy usage, and therefore USB 3 is enough, because you go for long-term exposures, like let's say up to 15 minutes. You do not have the problem with the frame rate.
Yeah.
And if you want to have high frame rate with high resolution in any case, then you have to change the bus, because you won't get all the data in time transferred.
Yeah.
So producing a high-speed astronomical camera is something that up to now is never done before. And we are in the need of something that is capable of that. So that you have a cooled camera, a cooled chip that goes below, let's say, 70 degrees below ambient. You need high frame rate, high resolution, high color depth. These are things that you normally do not use in astronomy.
Yeah.
And we have to find a compromise between high sensitivity, because with if you have just, let's say, a 1,000th of a second and have to record, let's say, in the nighttime up to a certain illumination power, then you have a problem. You normally do that with longer exposure times, but longer exposure times mean that within, let's say, 1 second, everything can happen.
So then what's the end? Do I, Richard?
Bigger pixel size.
Yeah. So what is the end, if we were to go into that direction, what is the end result? Are we going to record that SDI to the cloud, or is it going to record local? Well, I'd have to go to the cloud. And do we have enough bandwidth to do that? Because SDI is a big file, especially on a 1-inch chip. We're talking about gigs.
Sorry, what are you talking about here? Why the cloud? Why are you talking the cloud now?
Because of the storage.
SDI is huge. Huge.
Yeah, but it's only locally for processing. We do not store these huge. I mean.
Okay, so that's the question.
So,
That means,
are we
that
talking?
means that
We're not talking about our normal station setup, the Sky360 station. Okay, we're talking here about a monster machine, right?
Right.
Okay. Anyway, got it.
So how are you going to store it? What are you going to put it on?
Well, if it's a monster machine, then I can show you how you can give you a 1 petabyte storage.
That's my point. Just trying to get Richard's mind in behind it. That's all I'm saying, is that you're going to need a petabyte. 1 terabyte is nothing to video. Absolutely nothing.
Yeah.
So that's all
you're
I'm
working
saying.
with petabytes with video. I mean, almost any AI, it's petabytes.
Yeah.
And once you fill it up, which will be fast, you will have like a monthly job to delete data that you already processed, because it's a lot.
Yeah.
Yeah. Okay. Yeah. Let's talk about the monster further on down the line when we have after the alpha. Okay.
We didn't finish. Maybe you're talking about monster.
Pardon me?
We didn't finish the basic model. You're talking about monster model.
No, it's not a monster for Sky360. It's this is the need of what Skinwalker Ranch should apply. It's a different product.
Okay, sorry.
Yeah. So, okay, guys, it is 3 minutes to the clock. I just want to throw out two more things. The developers that they receive the camera and the optic will also receive a 3D printed adapter that you use so to add the camera and the optic from 2 sides. Then you get a camera. Pardon me?
I need that.
Yes, of course, everyone needs that. And then you can put that device then onto an enclosure, or if you don't have an enclosure or you don't get one, we also had a so-called camera carrier for the table. So it is something like of 18 centimeters height, and it carries the whole camera, and carries it stable, so you can put the cables underneath, so it's a lot of room. It's 18 centimeters height, so you will also get these. All right. That's it for now. Nothing more on my list. I'd say we see each other again in a week, and everything else during the week on Discord.
I'm putting a calculator. I'm putting a.
Pardon me,
yeah.
Tommy? Go ahead.
I'm putting a calculator in the Hangout section for everybody to look at for the video to figure how much storage you need.
All right. Cool.
It's in the Hangout section.
Cool. Thank you.
Thanks.
Okay.
Okay.
Thanks. So guys, see you. Bye.
See you. Bye.